Hello everybody, I'd like to present the two-way ANOVA. In this test, we have two factors. The first factor has two levels, while the second factor has three levels. For the unbalanced design. Unbalanced design means that the observations in each group of the experiment are not equal to each other. This is our question. A researcher was interested in whether a student achievement in three classes, which are the math, science, and English, were influenced by adopting two new teaching techniques, way A and way B. The scores of the student were recorded in the below table. What is needed is to conduct the two-way ANOVA to test the hypothesis. The value of the significant level is 0.05. Of course, I will do it manually by hand. So, in this test, we have two factors. The first one is the teaching techniques. We have two ways, way A and way B, so we have two levels for this factor. And for the second factor, we have the classes, and this factor has three levels. So this design is called 2 by 3 ANOVA, sometimes called factorial ANOVA because it contains more than one factor. The design is unbalanced because simply if you check for the total observation for each group, you will see that they are unequal. For example, for this group, number of observation is equal to 5, while for this group, for example, number of observation is 7. So it's called unbalanced design. This is the two-way ANOVA table, which we need to fill in. In case of two-way ANOVA, we have three sets of hypotheses we need to test. The first one is for the first factor, which is the teaching ways or teaching techniques, and the second one is for the classes, and the third one is for the interaction between the two factors. Also, the table contains the degree of freedom and sum of squares, SS, the mean square, MS, and finally we can calculate for the value of F, and we will compare this value with another critical value, which is called the critical F. So this is the table which we should fill in. Let's first understand all the details for our question in order to understand the procedure. First of all, we have two factors, two independent factors. The first one is the teaching techniques, or simply teaching ways. we have A and B. So the independent factor, the first one is the teaching techniques, and the number of levels for this factor is 2. So A is equal to, so we can consider A1, the way A to be A1, and simply we can consider way B to be A2. For the second factor or second independent factor, we have the classes. And as you notice here, we have 3 levels for this independent factor, which are simply the math, the science, and the English. So the second independent factor is the classes with 3 levels. So B here is equal to 3. Simply we can denote for math B1, and for science B2, and for the English B3. Regarding the dependent variable, we have here the scores of the students after conducting the treatments. So the dependent variable is only one dependent variable. It is the student's achievement, which is simply the scores of the students. Number of treatment groups. We have simply 2 levels for the first factor and the 3 levels for the second factor. So simply we can multiply both levels. So we get number of treatment groups, A times B, which is 2 times 3. So we have 6 treatment group. For example, this group is the science class, which has been taught by using the teaching techniques way B, and number of observation for this group is 5, or sometimes it's called number of replicates. It is 5. So we have 6 treatment groups. Regarding the total number of observations, which is denoted by capital N, it is simply the total number of observation for the 6 groups. So for this group, if we count for the number of observation, we find 7. For the science class with way A, again we have 7 observations, and for the English class with way A, we have also 7 observations. While for the math, which has been taught by method or way B, we have 6 observations, and for the science class, which has been taught by way B, we have 5 observations, and finally for the English class, which has been taught using way B, we have 6 observations. So simply we can count for the total number of N, and it is 38. And as you notice, the number of observation in the 6 groups are not the same. So it's called the unbalanced design. So these are all the details for our question. The total scores for the student has been calculated horizontally. For example, for way A, we have 127, the total of the observations, while for way B, we have 120. Regarding the second factor, for the math, we have 89, for the science, we have 81, and for English, we have 77. And the total number of observations, we have 247. First of all, let's state the hypothesis for this question. As we know, for the two-way ANOVA, we have three sets of hypotheses. The first one is for the first factor, which is the ways, while the second one for the second factor, which is the classes, and the third one is for the interaction between the two factors. For the ways, we have the null hypothesis, which state that the achievement or the score by using way A is the same as the achievement or the score for way B. For the alternative hypothesis, for this factor, H alternative, it states that the average of the scores for the students using way A is not the same as the average for the student by using way B. The same for the classes. The null hypothesis for the classes states that the mean for the math class is the same as the mean for the science class is the same as the mean for the English class. The alternative hypothesis states that at least one mean is not equal to other. The third set of hypothesis is for the interaction between these two factors. So the null hypothesis for the interaction states that there is no interaction. There is no interaction between the teaching techniques or teaching ways, which is factor 1, and the classes, which is factor 2. While for the alternative hypothesis, it states the opposite, which means that there is an interaction between the two factors. So these are all of the sets of the hypothesis. We need to test all of these tests. So in this case, we have 3 values for F, 3 calculated value and 3 critical values we need to compare between them. Let's start the calculation by hand. First of all, we can simply calculate for the degree of freedom. For the first factor, which is the ways of teaching, or simply the ways, we have 2 teaching ways. So we subtract 1 from 2, we get the degree of freedom for the ways, which is A minus 1. A represents the number of level for the first factor. So this is the degree of freedom for the first factor, which is the ways. It's 1. For the second factor, which is the classes, number of levels, we have 3 levels. So simply we can calculate for the degree of freedom for the class by subtracting 1 from the number of classes, or simply b minus 1. So b, we have 3 levels, minus 1, it is 2. So this is the degree of freedom for the class. Now we need to calculate for the degree of freedom for the interaction between the two factors. Simply we can get the degree of freedom for the interaction by multiplying the two levels, level A and level B. So A minus 1 times B minus 1. So A minus 1 is 1 and B minus 1 is 2. So the degree of freedom for the interaction is simply equal to 2. Now we can calculate for the degree of freedom for the error. And the formula is df for the error is capital N minus A times B. Capital N represents the total number of observations. So we have capital N 38 and A we have 2 and B 3. So 38 minus 6, which is equal to 32. So this is the degree of freedom for the error. And simply we can calculate for the total degree of freedom by subtracting 1 from the total observation. So capital N is 38 minus 1, so we have 37. There is another way to calculate for the total degree of freedom, simply by summing up the degree of freedom for all. So we have here 1, and here we have 2, and here we have 2, and here we have 32. So the total is simply 37. So we can fill the degree of freedom inside the two-way ANOVA table. This is the degree of freedom for the ways, it's 1. For the classes, it's 2. For the interaction, we have 2. For the error, we have 32. So the total of all of these degrees of freedom is simply 37. Now what is needed is to calculate for the sum of squares, which is simply abbreviated by capital SS. Before starting the calculation for the SS, we need to calculate for the correction factor. The correction factor formula is simply the summation of the total observations. We square this value and divide it by the total number of observations. So the summation of y is the total of all of these records or scores, starting from 5, 6, 4, and ending by 7, 6, 9. So we can substitute in the formula of the correction factor. So we have we have here 38 observations. We make the summation and we square it and divide it by the total number of observations. As you notice here, the total scores or total observation has been calculated. So if you proceed, the correction factor is simply equal to 147. We square it, divided by 38. So simply the value for the correction factor is 1605.5. The correction factor is needed to calculate for all of the SS for all the variables. Now we can simply calculate the sum square total or the SS total. The formula for calculating the SS total is simply we sum all of the squares of the observation and then subtract the correction factor. So the summation of the squared observation, we have 38 values. We need to square all of these 38 values. Simply you can use the Excel in order to facilitate this calculation. So the total or the summation of y square is 1747. So simply now we can calculate for SS total. This is the summation of the squares of the observation, and this is the value of the correction factor. So this is the value for SS total. So SS total is equal to 141.5. Now we need to calculate the SS for the first factor, which is the SS for the ways. First, we need to calculate the observations for the first level for way A, and then we need to calculate for the observation of level 2 for this factor, and it is simply here, it's already calculated, and we need to count for the number of observation for each. So the SS for this factor is simply summation of A1, and summation of A1 is simply, it's equal to 127 divided by N sub A1. N sub A1 represent the total number of observation for the scores related to the first level, which is A1. So these calculations are related to the first factor, which is A1. The same technique or same way, this is for the second level, and finally we can subtract the correction factor. So the summation of A1, as you noticed in the table, it is 127. So we square this number, and number of observation we have here. In this group we have 7, and in the science group we have 7, and the English group we have 7, so the total is 21. For the second level, for way B, the total of the scores or the observations is 120. So we square this value divided by 17. For this group, we have 6 observations. For the science, we have 5. For the English, we have 6 observations. So 6 plus 5 plus 6 is simply equal to 17. And this is the value of the correction factor. So simply now you can proceed in the calculation. You get the value of the SS for the first factor to be 9.61. So this is the way how to calculate for the SS for the first factor. The same technique can be followed in order to get the SS for the second factor, which is the classes. For the classes, we need to calculate the total observation for the math and the total observations for the science, and finally the total observation for the English. And it's already calculated. So we have 89, 81, and we have 77. Regarding the number of observation for the math, simply we have here 7, and here we have 6. So for the math, small n is equal to 7 plus 6, which is equal to 13. So this is the calculations needed for the first level of the second factor. For the math, it is B1. For the science, it is B2. And for the English, it is B3. This is the calculation for the second level, and this is for the third level, and this is the correction factor. The total of B1 is 89, and number of observation for this level, which is the math, is 13. For the second level, the total is 81. So we square the 81, and if you check for the number of observation for the science, by way A we have 7, while for science by way B we have 5. So 7 plus 5 is equal to 12, and for the third level, which is B3, the total is 77. So we square the 77, and regarding the number of observation, here we have 7 observations, and here we have 6 observation. So the total is simply 13, and this is the value of the correction factor. So now you can simply get the result. So the SS for the second factor, which is the classes, is equal to 6.63. So right now we have calculated the SS for the total, and the SS for the first factor, and the SS for the second factor. What is needed now is to calculate the SS for the interaction between the two factors. The SS for the interaction. In this case, we are interested in each group. For example, we need to calculate for the summation of this group. This group represents the math class, which has been taught by using way A. We need to have the sum, and we need to know number of observations. The same technique we need for all the 6 groups. So first, the formula to calculate for the SS for the interaction, we need first to calculate the unknown value, which is called the SS for the subtotals. And SS subtotal is simply the SS for the 6 groups. And we subtract the SS ways, which are already known, and subtract the SS for the classes. Again, it is already known. So the unknown value here is the SS for the subtotals. This is the formula for the calculation of the SS for the subtotals. It's equal to the summation of A sub I times B sub j. A sub I and B sub j represent all the 6 groups. We square this value and divide it by the number of observation and subtracting the correction factor. Regarding the total here, it's already calculated inside this table. For example, for A1, B1, this is A1, B1. A1, B1 represent the math class, which has been taught by using way A. The summation of all the scores is 37. For this group, for example, this group is group A2, B2. So the total observation for this group is 25. And if you count for the number of observation, you will find it to be 5. So you can simply now substitute for all the 6 groups. For example, this value here is for A1, B1. The total is 37, so we square it, divided by the number of observations, which is 7. This is for the second group, this is for the third one, this is for the fourth, this is for the fifth, and this is for the sixth, and this is the correction factor. So the value of the SS for the subtotals is simply 87.05. So now we can simply return back to the above formula in order to calculate for the SS for the interaction. So the SS for the interaction, this is the SS for the subtotals, this is the SS for the ways, and this is the SS for the classes. So the value of the SS for the interaction is equal to 70.81. Regarding the calculation for the SS for the error, we can get it by knowing all the SS for all the variables. So we know that the SS total is equal to the SS for the first factor plus SS for the second plus SS for the interaction plus the SS for the error. So simply we can move all the known values to the opposite sides. So the signs for these will be opposite. So SS error is equal to SS total minus SS for ways minus SS for classes minus SS for the interaction. And all of these SS have been calculated. So this is the SS total. This is the SS for the first factor. This is for the second factor. And this is for the interaction. So the value of the SS for the error is equal to 54.45. So we have calculated all the SS needed. This is for the ways, this is for the classes, this is for the interaction, this is for the error, and this is the total. What is needed now is to calculate the mean square, the MS. The formula to calculate for the mean square is simply by dividing the value of the SS by the degree of freedom related to that SS. So first, to calculate the MS for the first factor, which is the ways, we divide the value of the SS for the ways by the degree of freedom for that factor. This is the SS for the ways, and number of degree of freedom is simply 1. So this is the MS for the first factor. The same technique we can proceed for the second factor, which is the classes. This is the value of the SS for the classes, and this is the degree of freedom for the classes, and this is the value of the MS. So this is the way how to calculate the MS for the classes. Regarding the interaction, we know the SS for the interaction, and we know the degree of freedom for the interaction, so the MS for the interaction is 35.41. So this is the way how to calculate the MS for the interaction. The remaining is to calculate the MS for the error. This is the SS for the error, and this is the degree of freedom for the error, and this is the value of the MS for the error. It is 1.70. So we fill all of these MS inside the two-way ANOVA table. What is needed now is to calculate for the value of F, the statistic F, or F calculated. We should have 3 values for the calculated f, first for the first factor, second for the second factor, and the third one is for the interaction. The formula to calculate for the f for the first factor, for example, is simply to divide the ms for this factor by the ms for the error. So the value of f for the first factor, f subways, ms for the ways divided by ms for the error. This is the ms for the first factor, and this is the ms for the error, and this is the value of the calculated f. Next, we need to calculate for the f for the second factor, which is the classes. So the value of the ms is 3.32, and the ms for the error is 1.70. So this is the ms for the classes, and this is the ms for the error, and this is the calculated f for the second factor. The remaining one is the f for the interaction. This is the ms for the interaction, and this is the ms for the error, and this is the calculated f for the interaction. So as you noticed here, we have three calculated values for f. What is needed now in order to complete filling the contents of this table is to determine for the critical value of f. And simply to calculate the critical value of f for the ways, we need to know three things. First of all, we need to know the value of alpha, which is the significant level, and we need to know the degree of freedom for the ways, which is 1. So degree of freedom 1, and we need to know the degree of freedom 2, which is related to the error. So for the ways, we have significant level of 0.05, and we have a degree of freedom first, which is equal to 1, and it's called the degree of freedom in the enumerator, and the second degree of freedom is the 32, which is called the degree of freedom in the denominator. So simply now we can return back to one of the f distribution table. So this is the f distribution table for alpha, which is equal to 0.05. To calculate for the f for ways, we need degree of freedom 1 and degree of freedom 32. So in this row, this is the value of degree of freedom 1, and regarding this column here, this represents the degree of freedom for the error, and we need it to be 32. As you notice here, we don't have 32, so we can make some manipulation or rounding, or simply we can say that the critical value of f for alpha equal 0.05 and degree of freedom 1 and the second degree of freedom is 32. We can use the Excel in order to get this value by using this formula. F inverse, then it will ask you to determine the value of the probability, so it's 0.05. Then it asks you to determine the degree of freedom first, which is 1, and ask you for the second value of degree of freedom, which is 32. So simply the critical value will be 4.15. Of course, the Excel will give you a precise value for f, but we round it for 2 digits. So this is the first critical value. Regarding the second factor and the interaction, notice that they have both the same degree of freedom, which is 2. So they will have the same critical value of f. So this is the function used in Excel in order to determine the value of the critical f. This is the probability. This is the first degree of freedom, and this is the second one. So it will give you 3.29 after rounding. So right now we know all the details or records we need to fill inside the two-way ANOVA. How to make a conclusion? The conclusion is very simple. We need to compare between the calculated value of f with the critical one. So let's understand this concept by these figures. This is the f distribution curve for the first factor, which is the ways of teaching. So this curve simply is the f distribution curve for degree of freedom 1 and 32. Regarding for the f critical, it has been defined. It is 4.15. The critical value of f divide the curve into two regions. The right region is the region that we reject the null hypothesis, and to the left of the critical f, it is the region that we accept the null hypothesis. The calculated value for the first factor is simply 5.65. It is greater than the f critical, and it is simply lies inside the rejection of the null hypothesis. So simply for the first factor, we conclude that we reject the null hypothesis, which states that the mean for the first way is the same as the mean for the second way. So we reject the null hypothesis and accept the alternative one, which means that the two means for this factor is not the same. So we have here a significance for the first factor. The same techniques, we use it for the second factor, which is the classes. But notice that the shape of the F distribution curve is not the same as the previous one, because this curve is related to the value of F for degree of freedom first 2 and 32. The critical value here is 3.29, and the area right to the critical value is simply, it is 0.05, and regarding the calculated value of F, it is 1.95. So 1.95 lies in the accepting of the null hypothesis region. So simply for this factor, we conclude that we accept the null hypothesis, which means there is no significance for this factor, which means that the means, the three means for the three classes, for the math and the science and the English class, they are the same. So we don't have any significance for this factor. Regarding the interaction between the two factors, this is the F curve for this factor. We have degree of freedom 2 and 32. And the value of the critical F is 3.29. And the calculated value of F for the interaction is significantly greater than the critical F. It is 20.83. So it is deeply inside the rejection, the null hypothesis region. So we conclude that we should reject the null hypothesis for the interaction and accepting the alternative one, which means that there is an interaction between the two factors. In order to understand the interaction more, let's see this plot here. The red line here represents the way A, and for the black one, it represents the second way or way B. In the above table, I have calculated the mean for each of the 6 groups. So, for the math group, which has been taught by way A, the average for that group is 5.29. While for the same class, which is the math, which has been taught by the second teaching way, it is greater, it is 8.67. So the math class has been influenced significantly by using the second way. Regarding the science class, by using the first way, the average is 8, while for the same class, the science, which has been taught by the second way, it is less, it's 5. So as you notice here, way B for the math is better than way B for the science. Way A for math is less than the way A for the science. So this is the meaning of the interaction. And related to the English, for the group which is taught by the first way, the mean is 4.86, while for the group which is taught by the second way, it's better, it is 7.17. So as you see here in the plot, there is an intersection between the two lines, and this is simply an indication for the interaction.
هذا برن علي أكثر من مرة وأنا بالجيم ما ردتش
مين هو؟
الكابتن.
الو، عليكم السلام، اهلين اهلا كابتن. لا 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 ما في مشكلة. خير ان شاء الله. بكرة اي ساعة؟ 9:15. طيب ولا يهمك يا سيدي. الله يعطيك العافية. إن شاء الله إن شاء الله. طيب شو بدهم أحسن من هيك يا سيدي، هذا المطلوب. لا حرام. ما بزبط نص ساعة، شو نص ساعة؟ ولا يهمك يا كابتن، تسلم. إن شاء الله إن شاء الله، ولا يهمك. الله يحييك، مع السلامة. بكرة 9:15 بده يجيك في بقول. ما حدا يطلع صوت نهائيا. So this is the way how to conclude for the interaction between the two factors, and also the non-parallel lines, the red line and the black line. This non-parallelism indicate an interaction. So this is all of the contents for the two-way ANOVA table. Regarding the first factor, which is the ways, the calculated value is 5.65 and it is greater than the critical one, so we have a significance here. So for the first main factor, which is the ways, the calculated value of f is greater than the critical, which is 4.15. So we reject the null hypothesis and accept the alternative one, which means there exists a significance for this factor. For the second factor, which is the classes, the calculated value of f is 1.95 and the critical one is greater. So the calculated is less than the critical, so we don't have any significance. This is the value of the calculated, and this is for the critical one. So we accept the null hypothesis, which means simply no significance exists in this factor regarding the interaction between the two factors. The calculated value of f is extremely greater than the critical one, so we reject the null hypothesis, which means that there is a significance for the interaction, or simply there is an interaction between the two factors. So this is all about the two-way ANOVA. If you have any comments, please write it down. Don't forget to click the like and don't miss to subscribe. Thank you.